is Gavan Narangala. This is regarding assessment 3 data wrangling. For this exercise, I have choose two data sets. One is from Australian government open data sets. It's got information about airline activities. The other one is from open flight dataset, which is again another open dataset including around all the information about airport and their ITA code especially. So we'll take a look at the airline activity dataset, which include Australian cities, international cities, some port information, and most importantly the maximum seats available with each scheduled route. If you go back a bit down, so I have checked the header of this dataset, which include the which city, and in and out mean that this flight is inbound and it's coming from Indonesia, and the route takes those 3 hops, which mean it's starting from DPS, that means Garuda airline airport, then the Adelaide, the next stop will be Melbourne. So and it's include all the information about the route and how many stops and all flights and maximum number of seats and the year and the month that scheduled flight took place. So and the most important thing is it got this route value, which gives the how the flight move around with this port, so where and the actually the source and destination and the whatever the middle hops they are landing on. So if you take a look at this this one with the 4th line, it says it's from Singapore to Darwin, then Adelaide, then it's Melbourne. So if you go down with the next data set, which is from open flights, it got all the information about the airport, and the most important thing is the ITA code, which is matching with the first data sets the route value. But as you can see, it doesn't show the single value. It's got 3 or 4 depending on the route, so we had to fix that thing in the later to get this thing to merge. So the second data set also got the extensive information around the airport, where it's located, latitude, longitude, and time zone, whether it's in daylight saving time, and the type of the airport, and the source, and the 2 different codes which use in the international airlines, which one is ITA and other one is ICO. The when you took a look at the second data sets, the airport data sets, it's got only problem it got is it doesn't have any column heading, so I have to add it to the data sets, inject in this line, and the we'll look into the in detail around the attribute and how they arrange. The airline activity data, which I got stored with the first dataset, so I call it airline activity. We got some of the values are not really factors. The 2 things are there. One is the route. The route value, it shouldn't be a factor, it should be a character, and the airline name should be preferred with the character. So I have changed the factor to character type. The second one, airline attribute, the only problem with the time zone, the time zone is considered as factor, so I have changed it to normal character. And the column name which is in the airports, it should be airport name, so it makes more sense. So I change that thing as well. So the final outcome is like this. So the the next one, as you can see that the first data set, it got this root value which have 3 or 4 things. So to merge the two data set, so I'm taking the source ITA code and put into the column, and the other arrival hops in another column. So it divide the data set, adding 2 columns to the data set, which divide this route thing to 2. One is departure route data and the other one is arrival hop. So in this example it says DPS ADL mail. So in the final outcome should be the departure route is DPS and the rest is in the other column. Then the other thing is in the airline activity, the factor in and out, that's giving INO. So I decide to it's relabel with income and outgoing, which gives you a better understanding about the dataset. And other thing is I added another column which in the dataset you got month number as a last row. So we change to month name, so the final outcome in this thing, so if you have month number and the month name as well, and the other 2 columns are departure route and the arrival route, which is originally from route, and I got the first as the departure route, the first 3 letters, which is the ITA code. And in this before the merging, I preferred in the airport dataset take only 2 columns, because it's not necessary to get all the columns. So I subset the airports dataset which include only the ITA code, which is important to the merging, and the airport name. So I do a left merge, so with the airline activity and the airports. So the final outcome is that you have the airline and the airport name, that is source airport name, departure airport name actually. So and after merging, the airport name is renamed as departure airport name. This gives the better understanding what was added. The other thing is whether this dataset is tidy or not. So at a glance it's almost tidy data, there's nothing to fix except for the first column, which have a month encoding, which is confusing this whole thing. Actually what happened is this original data set is set to start from this is number of days, which when you add 1900 and the 1st of December 1st of January to January 1st, with this number it will give the date name. So I fixed that thing in this thing. So now we got another new column called date, which is from the first column called month. So the outcome for this thing is like in the first, if you have 3985, once you do this arithmetic, so we got 2009 and 2, the exact day that flight went. The other thing is to add a new column with the arithmetics, and I've got this maximum mean number of maximum seats per month. So when I add that thing, so we'll get this final column which give the per month average for the for any airline or any airport. So this will give a and you given any month, say September, this is the average number. So when you're doing the other transformation, it's very important. The other thing is whether you have any null values or zero values. I couldn't find any null values. Only problem is that you have maximum number of seeds 0 in some columns, that is wrong, so I have choose to remove them. So the final outcome is almost all records got some kind of maximum seed. The second one, the scan 2 is looking for outliers, so I choose box plot for this. But when you box plotting all these values with the maximum number of seeds against the month, it got some outliers around 50,000 mark. But when you take a look at the data set, it's got several airlines with several airports, so we can't remove them. We need them to the if you do any further calculations, we definitely need them, so we can't choose them as outliers, so we decide to keep it as it is. So the other thing is when you order the month, I purposely set from November, starting from November, to capture the holiday season, so it gives better understanding when you have plots against this data set. And the transformation, in the transform, I choose first to get the what is the actual values in the data set. So initially I tested each and every airline and see what the maximum number of seats, how it's spread according to the month. But given a number of airlines in the data sets too many, so I choose only airlines have name China in the data set, so I choose them and plot against that particular data set. So what will got is bit of a left skewed data, which as I expected, November, December, January, February is a bit busy, so maximum number of seats available is higher than the other month. So that's the first thing to get. This thing is left skewed, and so the steps I choose is to apply logarithm function to the number of seats, so it will give scale down and bit more normalized approach to this data set. So the logarithm function applied in the ggplot's bar plot, so it will give some proper understanding how this data is separated and spread. So that's the final outcome of this data set.